Hello, my name is Keshwani. That's K-E-S-H-W-A-N-I, Keshwani. We are here because we want to improve our math skill. Whether we are preparing for SAT, GRE or GMAT, it doesn't matter. These math problems will help you. Help you in making sure that you know all the basic math concepts that you need to know in order to do well on these exams. The problem that we will solve today, it goes something like this. It says, in a Cartesian coordinate plane, the distance from A, and we are given the coordinates of A as x and 2, to B, which has the coordinates of 8 and 8, is 10. The question simply is, what is one possible value of x? What is one possible value of x? Apparently there are more than one. So first thing first, what does Cartesian coordinate plane mean? Cartesian coordinate plane is just a fancy way of saying this xy plane. There's your x-axis, there's your y-axis, and this is called the Cartesian coordinate plane. Plane as opposed to a three-dimensional figure. What they're saying here is that the point that they're talking about, they are on the plane, nothing is going to stick out. It's not a three-dimensional concept. Again, one more time I'm going to read the problem to you. So we are told that in a coordinate plane, the distance from A, which has the coordinates of x and 2, to point B, which has the coordinates of 8 and 8, is 10. The question simply is, what's one possible value of x? So let's draw 8 and 8 first. And in order to do that, I'm going to draw this y-axis a little bit out. I shouldn't have done that right here. Let's do it here. 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8. This 8, 8 is our point B. 8, 8. The problem is the x. Problem is the point A rather, where we do not know the x coordinate of A. We know the y coordinate is 2, which means that it goes up to 2. It goes up to 2. The y distance is 2. And we also know that the distance from A to B is 10. So the distance from A to B is 10. If this is A, then this distance is 10. Do you see a problem here? The problem is we do not know whether the point A that we're talking about is this point A or whether it swings this way. This one also has a coordinate of x and 2. This one also has the coordinates of x and 2. This is getting too crowded. You see, because we do not know what x is, we can't really tell whether it swings to the right or to the left. And hence the wording of the question, what is one possible value of x? There are two possible values of x. One of course is going to be here to somewhere, one of course is going to be way over there. So this point here also has a coordinate of x and 2. This one is also x and 2. Anyway, so let's get going. And we know that distance from A to B is 10. We're told that. Distance from A to B is 10. Or I was about to start solving the problem, and actually I gave it away a little bit already. I forgot to tell you, if you have not done so already, pause the video. You must always pause the video after I finish setting up the problem. pause the video, solve it yourself, and then continue watching it. Don't watch the whole video and then try to solve it yourself, because there's no bloody point in trying to solve it yourself when you've already seen how it is solved. The challenge is no longer there. Just give me 1 second. Very good. So hopefully while I was gone for a little bit, you probably paused and gave you a chance to pause and unpause it. So let's continue. Here we have to use what is known as the distance formula. The only difference is that I'm not going to use distance formula in the traditional sense of the words, where the kids go around memorizing this distance formula. And whenever you memorize something, whenever you commit something to memory, there's always a chance that when it actually comes the time to apply it, you're going to muck it up. You're not going to remember it properly. So I'm going to do the distance formula, but in a way that you're not familiar, that you're not probably used to. I'm going to use it in a different way, where it does not make it necessary for me to memorize the distance formula. I hate memorizing things. So here we go. This distance, let's call it D. From distance A to B, let's call it D. See, I'm talking about this triangle here. I'm talking about this triangle, A, B, C. I'm going to redraw this triangle down here. There is your A, which has a coordinate of x and 2. There is your B, which has a coordinate of 8 and 8. And therefore this point C would have the same y coordinate, because it's the same height. Y coordinate is going to be 2, and the x coordinate of C is going to be the same as the x coordinate of B, because they are B to C, line BC is parallel to y axis. So it has the coordinates of 8 and 2. That's how we find the coordinates of C. One more time. The x coordinate of C is the same as the x coordinate of B, because B to C is parallel to y axis. Similarly, the y coordinate of C is the same as the y coordinate of A, because the line AC is parallel to x axis, and so forth. And we know that this distance is 10. And I'm calling that distance D. So we're simply going to use the Pythagorean theorem. That's what it is. Most people do not realize, but this so-called distance formula that you go around memorizing is actually a Pythagorean theorem. It's actually an application of Pythagorean theorem. The distance formula, I'm going to say it one more time, the distance formula that you always have memorized, whether or not you realize it, unbeknownst to you, it has always been Pythagorean theorem incognito. It is Pythagorean theorem. I'm going to show it to you right now. So we're trying to figure out the distance from A to B. Let's call it D. D squared, because that's your hypotenuse. D squared equals this distance squared plus this distance squared. How much is this distance? Well, from here to here, the distance from A to C is going to be 8 minus x. 8 minus 8 x squared, plus the distance from C to B is going to be 8 minus 2. 8 squared. You see, do you recognize it? It's a distance formula. You see? Now, if you wanted to find the distance formula looks like this. In order to get rid of this square sign, you take the square root of both things. And when you take the square root of both things, there is your distance formula. You see? x1 or x2 minus x1, x2. I'm going to put it underneath so you can see it. Oh, this is your x2 actually, which is same as this one. x2 minus x1, x2 minus x1, and y2 minus y1. You see? Point C has a coordinate of x2, y1, because here A has a coordinate of x1 and y1, and B, because we are interested in a distance from A to B, that's the distance we are interested in. Therefore, A has a coordinate of x1 and y1, and B has the coordinates of x2 and y2. If B has a coordinate of x2 and y2, then this point here that we are drawing here, this should not have been a continuous line, this should have been a dotted line. this triangle that we came up with, this right angle triangle. And how do I know it's a right angle triangle? Because we're graphing perpendicular and this is parallel, so this has to be a right angle. So if the coordinates of B are x2 and y2, therefore the coordinates of C, point C, must be the x coordinate of C is the same as the x coordinate of, rather the y coordinate of C is same as the y coordinate of A, which is y1, because these are the same distance. Similarly, the x coordinate of C is the same as the x coordinate of B, which is x2. You see, x2 and y1. It's a simple application of distance formula. You see, 8 x2 right here, x2 minus x1. Our x1 is simply called x here. This is the comma, this is nothing. This is the comma. Our x1 is simply called x. Plus y2, which is your this y here, y2 minus y1, which is your 2. You see? That is your distance formula right here. That's how people write distance formula. But as you can see now, distance formula is nothing more than Pythagorean theorem incognito. I shouldn't have written it like this. I'm going to erase it, but I just wanted to show you that that's what it is. But we're not going to call it distance formula because it's just a simple Pythagorean theorem that we're applying. And Pythagorean theorem tells us that the square of the hypotenuse equals the square of this distance, which is 8 minus x, plus the square of this distance, which is 8 minus 2. And all we have to do is figure out x from here, because we already know that d is 10. So d squared is going to be 10 squared, which is 100, equals 8 minus x squared plus 8 minus 2 is 6, is 36. Bring 36 on this side, so 8 minus 8 x squared, 8 minus x squared equals 100 minus 36, which is 64. I'm skipping a few steps in between, but you can figure it out. And therefore 8 minus x equals square root of 64, which equals plus or minus 8. Again, as I told you, I'm skipping a few steps, so if you want to, when you do it yourself, you do it slowly and you do whatever it is that you have to do. So if it's positive 8, you bring it here, it becomes 8 minus 8 and then x goes over there. So x is either 0 or x is 16. Voila, there you go. They were asking for one possible value of x and we found both of them. X is either 0 or 16. So it turns out that the way I drew the picture, the way we drew the picture in the beginning, is in fact not the right picture. We now know that x is either 0 or 16. X does not stop here. X actually comes all the way here. So I'm going to redraw the picture. This side should have swung out more. I'm going to redraw it down here. Where can I draw it? Or better yet, let's draw it up here, because I don't want to actually erase that also, because that's a useful information. I'm going to erase the question because we don't need the question now. Now what we're going to do is simply redraw the picture so that we can actually see what the reality is, what the picture looks like in real. So here we go. One, two, three, four, five. I shouldn't have drawn that far out. The reason I shouldn't have drawn in such big chunks is because we know now we have to go all the way up to 16. So here we go. 5, 10, 15 and 16. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. So here's your 5, here's your 10, and here's your 15, and here's your 16. And we are at 8. 8 is right here. 8, 1, 2. This is 8, so this is 8, 8, which was our point B. And it turns out that the triangle that we're talking about doesn't stop here, it comes out all the way up to here. There you go. That's the triangle that we're talking about, either that or this, 16. Both of these distances will be distance of 10 because it's an isosceles triangle. This whole big triangle that is. And that's all. We were told that the distance from A to B, this is your A, and this is also A in the sense that when it happens to be here, so let's call it A2 and A1 if you like. Because there are two possibilities where point A can end up. It can either end up here if it swings to the left, or it can end up there if it swings to the right. But we were told that the distance from A to B is 10, which it is right here, distance from A to B is 10, and we were simply asked what is one possible value of x. And it turns out there are two possible values, 0 and 16. That's all, you're done. Listen, if you wish to get hold of me for personal private tutoring, either face-to-face or over the internet via Skype, I tutor for SAT, GRE, GMAT, and of course the TOEFL. You can go to any of these website addresses and send me an email, or you can go to keshwaniprep.com and you can send me an email from there as well. Alright? Thanks.